Now let's take a look at this figure 23-14, and we're figuring motor loads, which is load number 5. And in the illustration, you see we have 3-phase 460-volt motors, design B. We have a 10 horse, 20, 25, and 30 horse. And of course, you know, 220.50 and 220.14C basically says Article 220 doesn't calculate motor loads, and we're referred from Table 220.3 also over to 430.24 in the part that deals with 2 or more motors on a feeder or 2 or more motors with other loads. Now, in step 1, we start the procedure for calculating the load for the motors. First of all, before you ever deal with motor loads and calculations, go to 430.6A1. And it will refer you for 3-phase motors over to table 430.250. The 10 horse is 14 amps, the 20, 27, the 25, 34, and the 30 horse 40, selected from table 430.250 based upon the horsepower, the voltage, and you would select that then from the table, and that's where we pick up those full load amps, not the nameplate now. 430.6A2 tells us that the nameplate of the motor is strictly for the overload sizing. Now, in step 2, we perform the calculation, and everything is taken at 100%. So all those loads in step 1 that you see amp-wise, when you total them, in step 2, it's 115 amp. Now we want to convert that over to VA, so we use 831 for 480. Voltage times the square root of 3. So VA is equal to amps times the voltage times the square root of 3. So the 115 amps in step 2 is multiplied by 480 times the square root of 3, and we just use 831, and we come up with 95,565 VA. So 95,565 VA is the total. But now notice, if one of the motors happened to be the largest motor load, and you know, which that would be the 40 amp, 30 horse, then you would multiply it by 25% in the last calculation that we make, or you just figure the 40 amps at 125%. You could go either way. We just use the 125% is the final total. Then we only, it kind of ensures us we put the motor in at say 25% or 125% one time. And that's exactly what this figure 23-14 is illustrating to the user of the NEC.